Hey guys, welcome to Safi Mixed. In this video, I will let you know to find a solution to this one equation and finding P and Q, an integer solution particularly. Okay, there is a trick to find the integer solution. However, I would first like to have. However, first I would like to try the equation through a guess solution from a layman perspective, since the left side of this equation must always be equal to 8, and keeping that in view, I can write P plus Q plus 2P Q equals 8, and can guess that if this thing is equal to 4 and PQ is equal to 2, then 4 plus 4 equals 8, and I can construct two equations of the form P plus Q equals 4 and PQ equals 2. For these choices of these two, we can see straightforwardly that the right side is exactly equal to 8. But remember, this is not a correct way to solve the equation, because these choices do not lead to an integer solution for P and Q. And you can try that very easily. You can do that for yourself by first finding P from this equation to be 2 divided by Q, and substituting the value of P at this equation to make this 2 divided by Q plus Q equals 4. Or I can arrange this by multiplying this equation with Q like this: 2 plus Q squared equals 4Q. Or I can write this as Q squared minus 4Q equals 2 plus 2 equals 0. This is a quadratic equation, and if you use the root equation for the quadratic equation, you would get the value of Q equals 2 plus minus square root 2. And this is obviously not an integer solution. This is not an integer at all. So that is not the right way. And if you put this value in this equation, again, Q is not an integer, and if you substitute the value of P and Q into this one equation, you will see that the result of this side is not exactly equal to 8. Means the two sides do not agree of the equation. So approaching to the problem this way is not correct. So what we do, we want to manipulate the equation to put this in a special form. And that I can do by first multiplying this equation with 2. If I multiply this with 2, I can write 2p plus 4 pq plus 2q equals 16. Let me take 2p common from these two terms to put this in the form 2p into 1 plus 2q plus 2q equals 16. Now what I do, I add a 1 to this side of the equation and a 1 to this side of the equation. In doing that, now we can take 1 plus 2q present in this term, 1 plus 2q present over here. I can take 1 plus 2q common from these two terms and can put this one equation into the form 2p plus 1 times 1 plus 2q equals 17. Now this is a prime, but I can factor this into two factors by writing 17. I can write 17 equals 17 times 1, or I can write 17 equals minus 17 times minus 1. So we have two cases. I can factor this in terms of positive primes, and I can factor this in terms of negative primes. So we want to solve the equation for these two cases separately. When I use this form of the equation, I can write 1 plus 2p into 1 plus 2q equals 17 times 1. Now, one of these two factors, that is either 1 plus 2p equals 17 or 1 plus 2q equals 17. So whatever the case may be, we can either try it for both of them, or we can try it for, or we can try it for one of them. Nevertheless, whichever choice you may take, that will only swap the values of p and q, will affect nothing else. So what I do, I set 1 plus 2p equals 17 and 1 plus 2q equals 1, and solve for the values of the two parameters. So I can write 1 plus 2p equals 17, and this implies that 2p equals 17 minus 1, or p equals 16 divided by 2 equals 8. So p is equal to 8, and similarly I can say 1 plus 2q equals 1. 1, if I take it to that side, would become 1 minus 1, so this side would 0, and we are left with, alright, let me do 2q equals 1 minus 1, or q equals 0. So when, for this case, let me call this case 1. For case 1, the solution set, I would write it over here, is p q equals 8 and 0. And for case 2, what will we have? For case 2, I would write this equation in the form 1 plus 2p into 1 plus 2q equals minus 17 times minus 1. So I set 1 plus 2p equals minus 17 and 1 plus 2q equals minus 1, and solve for the two parameters minus 17. So this I can write like 2p equals minus 17 minus 1, or p equals minus 18 divided by 2 equals minus 9. So p for this choice is minus 9, and similarly if I set this to minus 1, I get 1 plus 2q equals minus 1, or 2q equals minus 1 minus 1, or q equals minus 2 divided by 2 equals minus 1. So the solution set for case 2 is in fact p and q equals minus 9 and minus 1. Now see, for case 1, the solution set is 8 and 0, that is both p and q are integers. For case 2, p and q are again integers. And now let's see whether these integers, this set of solution in this set of solution, satisfied the given equation or not. So we should see this as well. For the first case, I need to put these two values in the left side, and putting in the left side, p is 8 plus 2 times 8 times 0 times 0, and this equals, this thing goes to 0, this is 0, so we are left with 8. That is, the left side equals the right side, so the equation is satisfied. This solution is valid. Similarly, if I substitute these values in the left side, I get minus 9 plus 2 minus 9 minus 1 plus minus 1. This equals minus 9 minus minus plus, so this gives me 18, and minus 1. Minus 1 with minus 9 makes it minus 10 plus 18 equals 8. Again, for this set of values, the solution is satisfied. So we see that for this factorization, we have integer choices for both p and q, and that satisfied the given solution, the given equation. And for the second case 1, we have integer solution for both p and q, and the equation is satisfied. So you solve this equation this way, and we find the integers, the two different integer solution, or the two different sets of integer solutions. Thanks for watching.